All it takes is this little bit of code to get the amount of time from the previous frame to this one. When you call clock get delta, it returns a precise floating point value of the number of seconds that have elapsed since the clock was created or from the last time get delta was called. By calling this at the beginning of each render, we can know exactly how much time we should use when we rotate the drinking bird. This code is how we were rotating the bird, adding half a degree each frame. If our goal is to rotate 30 degrees per second, we replace the 0.5 degrees per frame with exactly this. As each frame passes and the delta gets updated, the object is rotated the proper amount. This works well while the browser window is visible, but an interesting thing happens if you start the demo in timed mode, set the frames per second, and then switch to another browser window and hide the program. When you come back in a while, you're likely to see the drinking bird spinning around and around. The problem is with our function that computes how much to rotate. The assumption in this code is that the rotation angle will never increase much beyond 103 or negative 22 degrees. However, when this window is hidden, rendering stops. When the window is exposed again, the renderer gets a huge delta, which the limit testing code doesn't deal with at all. The bird spins around and around incredibly fast for a while as the huge value gets damped out. There are a number of solutions. Here's one that locks the drinking bird directly to the time itself instead of the change of time, the delta. The method getElapsedTime gives how many seconds have gone by since the clock object was created. We take this time and multiply it by 30, the number of degrees per second. We know that the drinking bird sweeps through a 125-degree arc in both directions, for a cycle of 250 degrees total. By taking the modulus, the remainder after the division by 250, we get an angle between 0 and 250. If the angle is less than 125 degrees, we rotate the bird forwards. Otherwise, we rotate it backwards, adjusting for the starting and ending angles of negative 22 and 103 degrees. Now, if the browser window is exposed later, the time is always going to resolve to a proper angle. The moral is, when you design any animation driven by time, make sure it's bulletproof from large time changes between renders. By the way, there's one more mode in the demo called Wave. It's my attempt to make the bird swing back from the glass at a varying rate, instead of moving back at a constant number of degrees per second. This avoids a bit of the jerk that occurs when the direction is reversed. One nice thing about using the time as an input is that you can then decide what the angle should be at various times. I can't say my attempt is all that convincing, but at least it's a bit nicer.